We got one more ancient astronomer we're going to talk about, but to understand what he did for astronomy, we have to understand how the planets move. We have to understand something very specifically that's called retrograde motion. So here I am, I'm going to draw, and here's the orbit of the Earth. Here's the orbit of Mars. And you got to remember when the ancient people thought the Earth wasn't moving, right? Because Aristotle said the Earth isn't moving because he couldn't see parallax of the stars. And so what we have to do is figure out what they see, and what they see is there's a bunch of stars out here. They see the planets moving with respect to the stars. But the motion of the planets is actually a combination of the motion of the Earth and the planets simultaneously. So let's start with the Earth up here in its orbit. So the Earth is up here and it's going around this direction. Mars is going to be at this position in its orbit, like right here. Okay? Now Mars moves only about half as fast as the Earth or so. Because Mars is further away from the Sun, Mars takes almost 2 years, 600 some days to go around where we take 365. So if we look and we see Mars, and Mars would appear to be right here. Okay? Now, a little time later, the Earth has moved here to this position. And Mars moves about half as far. So what we're going to see is that Mars now appears in our sky to be like this. So Mars is moving in a downward direction in my diagram right here. Okay? Now if we keep going though, what happens is Earth moves to here, Mars moves to here. All right? And we draw our line through there, and Mars now is in this position. Still going down, but it didn't go down as far. And if we keep going, Earth gets to here, Mars to here, and you see that the position now is actually right here. Mars is turned around, is starting to go backwards. And if we keep going, it's going to keep going backwards for a while. So Mars is here. We draw our line. And my straight lines aren't very straight anymore, are they? It comes to here. Mars turns around. And if we keep going, Mars keeps going down here. What we find is that Mars is going to go like this, slow down, and then come back the other way. So Mars is going to make what we call a loop in the sky. This is called a retrograde loop. Retrograde just means backwards. So Mars' normal motion going this way is what we call prograde, or regular motion. But then Mars will all of a sudden stop going against the stars, go backwards, turn around, and go forward again. That's called retrograde motion. Very complicated, because if you say the Earth isn't moving, then you're trying to figure out, well, why does Mars stop and make these loops? And it's not just Mars. This happens for all of them. It happens for Jupiter and for Saturn as well. Okay? They all make these retrograde loops. And let's look at the closer planets, Venus and Mercury. Venus and Mercury, from the perspective of the Earth, so here we do it again. Here's the Earth, here's Venus. So what we'll see is the Venus will be very close to the Sun. So looking this direction, this is the Sun in the sky. We'll see Venus go out to a point where it gets to its maximum position. So Venus is going to go like this, then it's going to go back to its minimum position down here, and go back and forth. So Venus will always stay close to the Sun. It stays within about 47 degrees of the Sun, going from one side of the Sun to the other. It just stays close to the Sun. Mercury does the same thing, but it's only at 20-some degrees, so it makes a small thing. So Venus and Mercury never get very far from the Sun, where Mars, Jupiter, and Saturn go along normal, and then they make these loops. All right, so our next guy we're going to talk about is a guy named Ptolemy. And Ptolemy was trying to make a model of the solar system. And the idea of a model of the solar system was if you have a model, you have a way to predict where the planets are going to be in the future and where they were in the past. They didn't have that up until then, and it gives you an understanding of what's going on. So Ptolemy, this is how you spell it, with the silent P, lived from 85 to 165, and this is CE. Notice he was significantly later than the other Greeks that we talked about. In fact, by this point, Rome had taken over, and so that we were in the Roman era instead of the Greek era, but Ptolemy was still a Greek, okay? And he realized, or he created a model of the solar system. Now his model was kind of complicated, so we call it the Ptolemaic, or it's also called the geocentric model. Remember, geocentric, geo means Earth, so this is Earth-centered. All right, so how it worked was this. Here's the Earth in the center. And with the Earth in the center then, he said, okay, let's put everything going around the Earth. So here's the sun going around the Earth. This is the sun. And the sun takes 365 days to go around one. 365.25. Okay, the sun is actually very easy. It doesn't do any of the retrograde motion or anything strange like that. It just goes around in a nice circle every year. Okay? And then he said, oh, let's connect the line between the Earth and the sun. Oh, before I do that, I should put the moon in. The moon is very easy too, because the moon just goes around the Earth. Here's the moon. But the planets, Mercury and Venus, he had to put on circles inside of circles. So here's Mercury, here's Venus. So here's Venus. And here is Mercury right here. The idea is that the sun is on this line and the sun goes around the whole sky in 1 year. And then Venus actually goes on its own circle, but the center of that circle is connected to the line with the sun, so it never gets very far from the sun, and it can explain the motion of Venus in the sky. And then planets beyond the sun, like Mars, is out here. But he couldn't just put Mars on a circle because it had to do this retrograde motion. So what he did with Mars is he said, oh, here's Mars. Mars is going to be on a circle on a circle. And so the whole circle is spinning. This is called the deferent. This is called an epicycle. And so if you watch it over time, Mars would appear to go forward when it's going on this part. So it would appear to go like this, and then it would go backwards, and it would go forward, and it would make these retrograde loops. Exactly what we see in the sky. We see those because Earth is actually passing it in its orbit, but the model would make it work. So Mars was like this. Same thing for Jupiter. Was on its own epicycle. It was smaller. It makes a smaller loop because Jupiter's speed compared to the Earth is much a greater difference. Mars is closer to the Earth, so it actually takes us longer to pass it. And same thing, so Jupiter would go all the way around the sun, just running out of board space. And outside of Jupiter, we would have Saturn. They knew about Saturn as well. So this was Ptolemy's model of the solar system. And if you knew the speeds of each of these, so you knew how fast Venus is going on its circle, how fast the sun's going around, you knew Mars' deferent speed and its speed on its epicycle, you could figure all that out. He had many years of data, and he had used Hipparchus's data for a lot of this. And he calculated all the speeds, and if you knew where any of the planets were at a given time, you could predict this into the future. You could run the model ahead and say, oh, 10 years from now, this is where the planets are going to be. Now the question is it right? No, it's not right at all, because the Earth is at the center. We know now that the sun is at the center of the solar system, but it worked. And it worked really well. In fact, it took over 1,000 years before it started to get significantly off and people started to question it. So for a long time, everybody just accepted the fact that this was the way the solar system worked. That the sun was at the center, the Earth was at the center, it was a geocentric model, and because of that, you could predict into the future what things they saw. Now we have artist's interpretation of Ptolemy, and we have part of his book. He wrote a critical book. Here it comes. Now, he wrote a book called the Almagest, which outlined his belief of how all this moved. We don't know how accurate this picture is of Ptolemy again. This is probably an artist's interpretation. But this is him measuring the sky and figuring out the position. A little more history for you here. So Ptolemy wrote this book, which was elaborate, and again it was in the Library of Alexandria. It got destroyed, it was lost. One of the things about the Renaissance, when they started to relearn, is the first part of the Renaissance was relearning all the things the Greeks had already figured out. Well, what happened was they found one copy of Ptolemy's book, the Almagest. They found it over in the Middle East, in the Arab countries, Persian countries at that time. And so they translated it back into Latin at the time, and then they got spread around Europe. And that was people learning, oh, this was what Ptolemy's model. So the learned people were figuring out Ptolemy's model. Well, what happened is when they translated it back, it had the listing of the positions of these stars from Hipparchus, but it had been translated into Arabic. And so the star names, when they translated back,